don't like heights. Maybe they pushed me somewhere. I don't remember that, but I blame them. All right. So we're going to go through information that you have learned before. So let's look at natural numbers. The natural numbers, and you need to know your number systems. This was taught in grade 10 already to you, and when you were younger as well. But the natural numbers are the natural numbers you start counting as like a toddler. Okay? There are no genius toddlers out there that start with 0. I've never seen a genius toddler be like 0, 1, 2. Like they start at 1, correct? So these are your natural numbers that you naturally count as a child. So where do we start at when we're not a genius toddler? 1, and then we progressively go to what? 2, 3, 4. There's no toddlers who are like 4.5. There's none of them. They're not out there. So natural numbers are the natural numbers that you count as a child. You naturally start at 1, then you go to 2, then you go to 3, then you go to 4. No genius children involved here. Whole numbers are actually the natural numbers plus the number with a hole in it. A number with a hole is 0. 0 has a hole in it, correct? So natural numbers, the only difference between the natural numbers and the whole numbers is the number with a hole. So 0, and then all the natural numbers. 1, 2, 3, 4, 5. Then you hit junior high and your life was rocked. They taught you about integers. And you learned there was negative numbers in the world. Okay? Life was rocked. So, still, integers don't have decimals. They just have negative signs. But they could also have positive signs, right? So the integers contain the natural numbers, the whole numbers, but also the negatives, right? So as we go along, our number systems just add more numbers to them, but the previous number system contains everything that was in the other one. So integers, you would have like ... -3, -2, -1, and then all the whole numbers, which also contains the natural numbers. So in grade 10, your teacher often gives like a little diagram, and they have like a circle with a natural number in it, and then around that they have the whole number system, because the whole numbers are the natural numbers plus 0, right? Like the whole numbers encompasses all the naturals plus the number 0. And then encompassing all the whole numbers is the integers. So you have all the natural numbers in the integers, all the whole numbers in the integers, plus more, right? That's why the circle keeps going. And then they would always go like this. They'd draw like a box around it. And then here they would say rationals. And this would be irrationals. And then this was the real number system. So what is a rational number? A rational number actually includes the naturals, the wholes, oops, don't know what just happened. Naturals, the wholes, and the integers. But rational numbers also contain decimals that terminate and repeat. So anything you can make a fraction. So a rational number has naturals in it, wholes, integers, and then decimals that repeat or terminate. Basically, anything you can make into a fraction is a rational number. So some people will say to me, well, how is the number 7 a fraction? Well, what is every number over if it's not over a number? It's over the number 1, right? So 7 is a fraction. It would be 7 over 1. -5 is a fraction. It would be -5 over 1, right? So examples of that could be 7, -5, because I can put them over 1. But also, 3/4 is a fraction, is it not? And it is 0.75. And 0.75 is a terminating decimal because it stops. Terminate just means stops. So 0.75 is irrational. 0.4 would be irrational. 0.398 would be irrational. Any terminating decimal, because they can be made into fractions. Right? That's still irrational. And then repeating decimals are rationals because repeating decimals can be turned into fractions. So like 1/3. Okay. 1/3 is the same as 0.3 repeating, right? 3. So if it's a repeating decimal or a terminating decimal, one that repeats itself or terminates, it's rational. Irrational are the ones that don't repeat themselves and do not stop. What's the most common irrational number? Do you remember? Most people learn it when you have to learn circumference. Yeah, an area. It's pi. So pi is irrational because it doesn't stop and it doesn't terminate. It just keeps going on for life, right? Another one that people think is rational, but is irrational, is like 1.13141516. They say it repeats. It's not repeating. That's a pattern, right? 13141516 is not repeated at all. Nothing has repeated itself. It's just a pattern that keeps happening, but not repeating. So in order for it to be rational, it would have to be like 1.131313131313, right? And then the real number system contains all of them. So it's the naturals, the wholes, integers, the rationals, and irrationals. Then we talk about prime numbers. Does anyone know a definition of a prime number or an example of a prime number? Yeah.
A number that can be multiplied by itself
And
divided by 0?
no, multiplied by itself and 1.
Oh.
Yeah. So it has to have two factors. Two factors are numbers. Factors are numbers that multiply to give you that number, correct? So a prime number can have only two factors. Only two factors. So a lot of people, I wish I had their energy. They're trying to get something. So a lot of people will tell me that 1 is a prime number. It's not. What multiplies to give me 1? 1 times 1. So how many different factors is that? Just 1. It's the number 1, correct? So how many factors does this one have? It has 1 factor. And what did I say it has to have? Only 2 factors, or technically just 2 factors. And this one has 1 factor. So what am I going to put here? I'm going to say 1 is not prime. Why do you suppose I'm making a big deal of this? Do you think people think that 1 is prime all the time? Yeah. So people will list 1 as the first prime number. It is not. All right. So what would the first prime factor be? Even earlier. There's only one even prime number. Yeah.
4.
Nope. Nope, even. What's the very first prime number? Yeah. It's 2. Because what multiplies to get me 2? 2 times 1. That's 2 factors, isn't it? So 2 is your first prime number. You have to have 2 numbers that multiply to give it. So basically, it's the number 1 and itself are the only things that multiply to give you that number. There's no other numbers in the world that can multiply to give you 2, right? Just 1 and 2. Yes? What about 3? 1 and 3. Are there any more? No, so 3 is prime. What about 4? Is 1 and 4 the only thing that multiplies to give me 4? No, what else? 2 and 2. So it has 3 factors, doesn't it? So is 4 prime? No, it has to have only 2 factors. What about the number 5? 1 and 5 multiply to give me 5. Anything else? No, so 5 is prime. What about 6? 1 and 6, 2 and 3. So that's 4 factors. So is it prime? No. What about 7? 1 times 7 is the only thing. To be honest, the only even prime number is 2. It's the only even prime. So now when I get to 8, 8 won't be prime because 2 is the only even prime and 8 is even. 8 is 1 and 8, 2 and 4. That multiplies to give it to you. 9, is it prime? 1 and 9, but is there more?
3 times 3.
3 times 3. So 9's out. It's not prime. What about 10? It's even, so it's out. What about 11? 1 and 11. Is there anything else? No. What about 12? It's even, so it's out because 2 is the only even. And 12 is 1 and 12, 2 and 6, 3 and 4. It has a whole bunch of that, but that's 6. What about 13? 1 and 13, so it would be prime. 14, no, it's even. 15, 1 and 15. Is there more? 3 and 5, right? The moment you have more than 1 and 15, it's out. It's not prime. 16 is even. What about 17? Yeah, maybe prime. 1 and 17. 18's out. What about 19? Yeah, it's just 1 and 19. And then there's more, but we're going to stop there. So 1 is not prime. 1 is also not composite. It's the only thing that's neither of them. Composite is, it has to have more than 2 factors. So 1 isn't prime because it doesn't have 2 factors. 1 is not composite because it doesn't have more than 2. 1 only has 1 factor. So it's like its own little thing. It's not a prime or a composite. So when people tell me prime and composite are opposites, they're not. Because 1 doesn't fit into either of them. If something's an actual true opposite, everything in one is not in the other, and everything in one is not in the other, right? So prime is and composites are not opposite because the number 1 doesn't fit into either of them. So what's our first composite number? Not 1, it's not 2, it's not 3, it's 4, yeah. Because 4 has more than 2, it's 1, 4, and 2. 5 is prime, so 6 is composite, 1, 6, 2, 3. 7 is prime, 8 is composite, 1, 8, 2, 4. 9 is composite because it's 1 and 9 and then 3 and 3. 10 is composite because it's 1 and 10, 2 and 5. 11 is prime, 12 is composite, 13 is prime, 14, 15, 16 are composite. So technically everything that's not prime except for 1 is composite, correct? 18, 20, etc. So these are all just previous definitions you took in different math classes. We're just reminding you of what they are, okay? Multiples of 3. What number do we start at? 3, and then we go up by 3. We start at the number, go up by the number. That's what a multiple is. So we start at the number 3, and we go up by 3. So we have 3, then 6, then 9, then 12, then 15, then 18, etc. Right? So we start at the number and go up by the number. Factors of 12. So what's factors again? 2 numbers that can multiply to give you the number, right? Correct? So factors are 2 numbers that multiply to give you a number. So factors of 12. What multiplies to give me 12? 6 and 2. What else?
3 and 4.
3 and 4. What else? 1 and 12. So we often list them in little squiggly brackets and in order. So we do 1, 2, 3, 4, 6, 12. If you listed them out of order but still listed all of them, you would be right. We just usually list them in order. Divisible by 5. Is 10 divisible by 5? Yeah, what about 15? Yeah, what about 12? No. So if we divide it by 5 and we get a remainder, then it's not divisible, correct? Like 12 divided by 5 is 2 with 2 left over. Like it doesn't go in evenly, it would be a decimal. So if you typed it into your calculator and you went 12 divided by 5, you get a decimal. Do you agree? So divisible means it goes in evenly. It goes in evenly to the number. So if it's divisible by 5, 5 would be the first number. Because 5 is divisible by 5, it's 1. 5 divided by 5 is 1. 10 would be the next one. 10 divided by 5 is 2. 15 divided by 5 is 3. 20 divided by 5 is 4, etc. Okay, then we're going to flip over. So, that was all previous information. Now we're going to get some new definitions. This lesson is heavy definition-wise, but not most of the lessons in 30 actually are. Okay, so this is rare. So in mathematics, a set can be defined as a collection of distinct objects. For example, the number on the faces of a die form a set. Sets are usually denoted by capital letters or by descriptions inside curly brackets. An object in a set is referred to as an element. So one object in a set is an element. So if we're looking at the 6-sided dice, that for this example, the number 5 is an element of the numbers on the die, right? So if I wanted to list the elements of a set, say set A was the number of elements on a die. So set A is elements on a die, 6-sided dice or die. If I was listing the elements, I would say capital A because that means the set A. And then I have to use the squiggly brackets. You can't use round brackets. You can't use square brackets. If your squiggly brackets look like this, they'll accept it. They're not going to mark you on like, is your squiggly bracket perfection? Okay? If you have to, you could just literally make 3 little bubbles like that and you would count as the same thing. This means the set of. So the squiggly brackets mean the set of. So if you use round brackets or square brackets in mathematics, they do not mean the same thing. So do not use a round bracket or square bracket because you're like, my squiggly bracket sucks. And it's not even called a squiggly bracket. I don't know what kind it is called, but I call it squiggly. It's the mathematical term. So if you do square brackets, or thank you for catching that, the rest of the people nothing. Just sadness. Squiggly bracket is a joke. Like it's not the mathematical term. Squiggly bracket. So, our crowd. So we have round brackets and square brackets. Okay? Squiggly brackets mean the setup. So here we have A equals the squiggly bracket, the set of the values 1, 2, 3, 4, 5, 6, right? Because that would be what you would find on all sides of the dice. You find a 1, then a 2, then a 3 with little dots. Same thing. Then you could use it in a set of words. It would be the natural numbers less than 7. Does that make sense? Where does the natural number start at? What do you naturally start counting as a toddler at? 1. And then it says less than 7. So I'm going to stop at 6. Because it doesn't say less than or equal to 7. It just says less than 7. Okay? So that would get me 1, 2, 3, 4, 5, 6. So same answer. And then this is just written in set notation. X is less than 7. X is an element of the natural. So this is what we need to know. The curly brackets, I call them squiggly, is read as the set of. The straight up and down line in mathematics means such that. Your teachers have taught you that in the past. And this little C, kind of weird looking E-ish thing, means a member of or set of. Or an element of. And an element of is often what we would say. We would say X is an element of the natural numbers, right? Like that's how your teacher just often was reals in all the past things. In grade 11, it doesn't matter what course you were in, you guys talked about quadratics. It doesn't matter if you're in 20-1 or 20-2. And when you did the domain of a quadratic, it was X is an element of the reals, right? It was XER because it kept going on for life. And then you'd say Y is less than or equal to 7. Y is an element of the reals, right? You did that little symbol. So this means element of. And the other thing is the number of elements in a set A is written as n of A. And the number of elements in set A was 6. There were 6 of them. Not the number 6. There are 1, 2, 3, 4, 5, 6 elements in A. Now, why the heck would they ask you for the number of elements in something and not what the actual elements are? Numeric response. That's the reason why. So if your answers are the elements that are in set A is 1, 2, 3, 4, 5, 6, that's great, but there's 4 numeric response boxes. So you can't fit that into 4 numeric response boxes, right? So they might ask for the number of elements in A, and the answer would be 6, and that fits in a numeric response box. Okay? So here it says, note that the number 2 belongs to set A, but the number 8 does not belong to set A. So how you can show that is 2 is an element of A, so 2 is in the set A, whereas A is not an element of A. That's what that little bracket means. And the order of listing the elements in a set does not matter. So if you list 1, 2, or you list 2, 1, or you list 1, 2, 3, 4, 5, 6, or you listed 1, 3, 5, 6, 2, 4, it doesn't matter the order. It's just that you might miss something if you don't do it in order. So I didn't even remember which ones I stated when I was doing it. All right. So here we have, consider the following 2 sets. So we have set P and we have set Q. How do we know they're sets? Because they're capital letters. Okay. P is stated as whole numbers less than or equal to 3. So in words, I feel like it's a little harder to know what the heck numbers you're getting to deal with when they give you words, right? So I will always list the elements in each set first. So I'm going to list P equals the set of, and then I'm going to list those numbers that fall in there. So it's whole numbers. Where does the whole number start at? 0, the number with a whole, correct? So it starts at 0. And we need less than or equal to 3. So where are we going to stop at? Yeah, we're going to stop at 3. If it just said less than 3, where are we going to stop at? 2, right? So you have to read. If you're someone who hates word problems, sorry, 30-2 is almost all word problems. The good thing is you will overcome that issue. Like if I had claustrophobia and you kept like making me do things in tight spaces, I would overcome it. Same thing with you guys, because I do have claustrophobia. You guys, if you keep getting word problems and word problems and word problems, they don't seem overwhelming anymore because they're all word problems. You can't bypass them. Yeah. Yeah. So, less than or equal to 3, whole numbers. So I start off at 0, and then 1, 2, and I stop at 3, we agreed. Correct? Now Q are the even whole numbers less than 10. Now if this was a diploma question, they would have to specify if 0 is even or not, because it's kind of a neutral number, but 0 is even. So we're going to put that. 0 is considered even. And I have to, so on a test, often they won't say whole numbers less than 10. They'll say natural numbers less than 10, because 0 isn't counted at all then. It's not a big issue, right? It's completely bypassed. So Q are the even numbers, even whole numbers less than 10. So I'm going to start at 0. Even means divisible by 2. I can divide 2 and get a nice little number out of it, right? Not a decimal. So I have 0, then 2, then 4, then 6, then 8. Do I put 10? No, because it says less than 10, so it doesn't include it. If it said less than or equal to 10, I put the 10. So I stop here. Now, complete the following. N of P. This little n means the number of elements. And in this case, in P. So that means I count them. So I go to P, and I count how many there are. How many distinct elements? Distinct means different. How many distinct elements are there in P? 0, 1, 2, 3, which is 4. Most of you are showing me a 4. So I would just go equals 4. So that's the difference. If I say determine the elements in P, or what is set P, you would go P equals and you'd list them all. But if I ask you for the number of elements in P, you count them up and tell me a total number. Okay? So P is this. N of P, or the number of elements of P, is 4. They're very different. Okay? And then this one, N of Q, how many are in Q? 1, 2, 3, 4, 5. Okay? Difference between just giving you a cue or saying and a cue. All right, flip over. So this is more terminology. Like I said, this is more terminology than you're going to get in a week normally or a month. So it's just heavy weighted at the beginning, but it will get better. So here it says, Betty is defining sets using non-negative single-digit numbers. Single-digit numbers are the numbers like 1, 5, 9. 10 is a double-digit number, right? 20 is a double-digit number. 37 is a double-digit number. 467 is a triple-digit number, or a three-digit number, right? So we're doing single digits. From the list of non-negative single-digit numbers, we want the even numbers, and we're going to include 0. Because it says non-negative, so 0 is not negative. Single digits. So what options do I have for even? 0, then? What next?
2.
2, then?
4.
Then?
6. 8.
Then? 8, and then I stop, correct? Because 10 is even, but it's a double digit. It's a two-digit number. Whole numbers, where do I start at? 0. Whole numbers less than 7, where do I stop at? 6. So I'm going to have 0, 1, 2, 3, 4, 5, 6. And then I have odd numbers less than 7. So what's the first odd number that's a single digit number?
1.
1. Then?
3.
3. Then?
5.
Then I stop because it says it's less than 7. So this is an important terminology. Universal set. So this is new. Everything else we did, like primes, multiples, rationals, rationals, irrationals, all that was repeat. This is new. So your universal set. So within the context of any problem in set theory, there generally is some largest set that we have in mind. We refer to this as the universal set. It is the set that contains all elements under consideration and relevant to the problem. So we want to state the universal set of the above. Well, up here, I had to, here it said, for every single one of these 3 sets, I'm only allowed to use the non-negative single-digit numbers. Correct? They limited me to that for all 3 sets. So if it's something that limits you for all of the sets, that's the universal set. So in this one, the universal set, which they use a U with a little, kind of like a horseshoe. The universal set equals the non-negative single-digit numbers. So if I want to list that as a set, what am I going to start at? What number? Non-negative single digit. So I said we could include 0, right? It was just because I had to say that or not. So we start off at 0, and then we go till when? What number is my last single digit? 10? Is that a single digit? Or is it a double digit? Double digit. So I stop at 9 when it says single digit. All right. So then we have a subset. This comes up a lot in math. A subset of a set is a set that contains some or all or possibly none of the elements from the previously defined set. Sounds way more complicated than it is. All sets we deal with in a problem must be subsets of the universal set, and every set is a subset of itself. So in set notation, the symbol, this little sideways U, this represents subsets. And this is your formula sheet in blown up version. You're going to get this exact same formula sheet without the black lines. This is your formula sheet. It looks exactly like this. I have no choice. This is what you get. The diploma picture formula sheet. Okay? But if you look here, it has this sideways U, that's a subset. And do you see how this upwards U is union? You see why a universal set has to have those little like lines on the top? Because if not, it is union, which is totally different. So this little sideways U is subset. So here it says, for example, set E is a subset of the universal set because all the elements in E are in the universal set. So what does that mean? So if I go E is a subset of U, it means all the elements here are in here. All elements in E. That's an E, even though it doesn't look like it. Are in U. So whatever one is listed first has to have everything in it. So example, E has 0, 2, 4, 6, 8, correct? E has 0, 2, 4, 6, and 8. Does U, which is the one after it, have 0, 2, 4, 6, and 8? Yes, so E is a subset of U. So for example, just a totally side example. Everyone put your pencils down because I want you to understand. We're not writing this down, we're just paying attention. If I make a new set and I call it set C, and I say it has 1, 2, and 5 in it. And then I say there's also another set, it is E. There's an E already, that looks stupid. Let's try that again. You're not writing this down, you're just paying attention. I'm going to say there's a set Z. Okay? And it contains some sort of elements. We agree? Don't know what those are, but there's some set Z. And then I say to you, okay, well, just so you know, C is a subset of Z. So that means all the elements in C have to be in Z. We agree? So what elements are in C? 1, 2, and 5. We agree? So they have to be in Z as well. So Z has to, if this is a true statement, if C is a subset of Z, Z has to contain at least 1, 2, and 5. We agree? That's all it has to contain, actually. Z could be 1, 2, and 5, and then they would be subsets of each other. Now, I can add anything randomly to it, and C is still a subset of Z. So if I want, I can say, okay, I also want Z to have 7 and 9 as well. Is C still a subset of Z? Is everything in C in Z? Does Z have more now? Yeah, it can have more, or it can have only what that is, but then it's a subset. So I'm going to give you a totally separate one. Say I give you B has -1, 4, and 6. And then I say Y has something. And I say B is a subset of Y. You tell me what Y could be. Give me an example. What could it be?
-1, 8, 0, 4, 6.
Why did I leave -1, 4, and 6 in blue? To prove to you that everything in B is now in Y, correct? And then you added a 0, which is perfectly fine. I could add a smiley face for all it matters. Oops, doesn't want me to. It's fighting. I could add smiley face. Would that still be a subset of each other? Yeah. Is this true, though? Is Y a subset of B? Is everything in Y in B? No. So this is actually not true. So the only way they're subsets of each other is if they're actually the same set. You know what I mean? They have to have this contain the same numbers. Now, in order for something to be a subset of something else, so for example, if B is a subset of Y, Y has to have at least what B has, right? So if B has 3 elements, Y has to have at least 3 elements. So I know that this is not possible because Y has 1, 2, 3, 4, 5 elements and B has 3. So how could I have these 5 and then something with 3 elements, right? So it doesn't make sense. You can pick your pencils back up. We're going back to this. So here it says, is set E a subset of set L? Is set O a subset of set L? So I want you guys to tell me that. Is this true? Is this true? Looking up at E and O and L at the very top of your page. You tell me if they are. You leave them like this. If they're not, you put slashes through them. Try it out. Is E a subset of L? Well, let's go up here. Is everything in E in L? So E has 0, L has 0. E has 2, L has 2. E has 4, L has 4. E has 6, L has 6. E has 8, L doesn't have 8. So is E a subset of L? No, because everything in E isn't in L. And if you had to explain that they're not, you'd say, well, E has the element 8 and L does not. Therefore, E is not a subset of L, right? You could explain it with words, could you not? Okay, what about O and L? Well, O has 1, L has 1. O has 3, L has 3. O has 5, L has 5. Is O a subset of L? Yeah, and how could you, if they asked you to describe why, you would say, because every element in O, which is 1, 3, and 5, is found in L. Therefore, O is a subset of L, right? Okay, what is the empty set? Another definition, but it's trying to draw weird. The empty set is a set that contains no elements. It's a set that contains no elements. So the empty set is a subset of every set. That's a key thing that people forget about. The empty set is a subset of every set. The empty set is listed as a 0 with a slash in it. If you forget, not a big deal. It's actually on your formula sheet. 0 with a slash there is the empty set. Okay? And we talk more about that later. It doesn't make a ton of sense right now. And then the complement of every set. The complement of set A is the set of all elements in the universal set that are not in A. Set A are the ones all in the universal set but not in A. And its complement is denoted with this little apostrophe, almost. It's called the prime. So we want the complement of set E listed down here. So the complement of set E, that's E, with a little prime symbol. And it shows you complement here too. It's on your formula sheet. Okay? So we want what's not in E, but in the universal set. That's what the complement is. So basically complement is the opposite of. Okay? So if I look in E, E has 0, 2, 4, 6, or 8. The universal set has 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Correct? So what's not in E, which is the complement of E, but in the universal set? So E has 0, 2, 4, 6, or 8. So the complement of E would be 1, 3, 5, 7, and 9, wouldn't it? It's everything that's in the universal set but not in E. It's just the opposite. So nothing crazy. So the complement of E would be 1, 3, 5, 7, 9. And then we're going to flip over for example 2. I don't know how it got bumped, but it got bumped. Okay. Here it says, consider the following two sets. A are the natural numbers. Natural numbers, what do we start counting naturally as a child? From 1, right? No genius children here. Natural numbers less than 20 that are divisible by 3. Natural numbers less than 20 that are divisible by 5. Why is the set of natural numbers less than 20 a suitable universal set? Did I limit both those sets to be the natural numbers less than 20? Is that what it says for both of them? So it's because both sets are limited to the natural numbers less than 20. So I want to list the universal set up here. So I always list it. Some people try and get away without listing numbers because they don't want to write more. That doesn't bode well for math. Always write out everything. So natural numbers start at 1. Less than 20 stops at what? 19, yeah, less than 20, so we stop at 19. So we're going to write these all out. Please make sure that you write everything. If I'm writing it, you can write it. We're working together as a team here. If I'm writing it, you would be writing it. So 1, 2, 3, 4, 5, 6. People who don't write these out are often people who make oopsies. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And I stop at 19 because it's less than 20. So we want the elements in A. We have to list the elements that are in A. So A are the numbers from 1 to 19, because the number is less than 20. They're divisible by 3. Which of those numbers are divisible by 3 from 1 to 19? What's the first one? 3, then 6, then 9, 12, 15, 18. Now I'm going to not do number 2 first. I'm going to do 3 actually first. 3 is the complement of A. So what's the complement of A mean? It means I go to the universal set and I pick every number but the ones in A, correct? So I know it's a lot of numbers. I don't care. You need to write them. So we're not going to write 3, 6, 9, 12, 15, 18, but we're going to write every other number. So we're going to write 1, 2, not 3, 4, 5, not 6, 7, 8, not 9, 10, 11, not 12, 13, 14, not 15, 16, 17, not 18, and 19. So remember, when you're listing the complements, if you take the 2 complements and you took all the elements in both of them, you should get the universal set back, correct? Because the 2 of them should make the universal set. If you're missing a number when you do the 2 of them that's in the universal set, then you have a problem. Okay, elements in B. Number 2 has B. What's my first one? Divisible by 5, yeah. 5, then 10, then 15. For C, it says, write the description of the elements of the complement of set B in words. So if B is the natural numbers less than 20 that are divisible by 5, the complement of B would be what? The natural numbers divisible by 20, what? Instead of divisible, the natural numbers less than 20 that are divisible by 5, we're going to say that are not divisible by 5. Now here it says set C are the natural numbers less than 20 that are multiples of 6. Multiples start at that number and go up by that number, correct? So which numbers are multiples of 6 that are natural numbers less than 20? Yeah, 6, 12, and 18. Then it wants us to answer this. Is C a subset of A? Is C not a subset of B? Is the complement of A a subset of the complement of C? Try these out. State whether they're true or false. So is C a subset of A? That means everything in C in A. Well, let's look at C. C is 6, 12, and 18. Is that in A? 6 is in A. 12 is in A. 18 is in A. So is C a subset of A? True. Is C not a subset of B? So is everything in C not in B? Well, let's look at C. C has 6, B does not have 6. That is not B. C has 6, B does not have 6, correct? So this is immediately true. Now the complement of A is a subset of the complement of C. Well, I'm going to draw the complement of C because I haven't written it out yet. It's everything but 6, 12, and 18. I know it takes time. I'm still doing it. 1, 2, 3, 4, 5, not 6, 7, 8, 9, 10, 11, not 12, 13, 14, 15, 16, 17, and 19. So now I have to see if everything is in not A is in not C. So everything in the complement of A is not in the complement of C. So 1 is in complement of A, it's in the complement of C. 2, 2, 4, 4, 5, 5, 7, 7, 8, 8, 10, 10, 11, 11, 13, 13, 14, 14, 16, 16, 17, 17, 19, 19. Is it true? Yes. So make sure you draw out the complement. Everything in the complement of A is found in the complement of C. So this is true. What if I wrote them backwards? What if I said this? The complement of C is a subset of the complement of A. Is everything in the complement of C in A? Are all these numbers in C and not A? No. 1, 2, 3 isn't in this one, correct? So you can't reverse these and say it's true. The complement of C is not a subset of the complement of A. So you're going to work in the next 10 minutes, and if you work hard, you will finish these. This is the workbook. So when I say workbook, you're going to go back and grab one. This is the only stupid assignment that people have wrote in my book. Please don't write in these books. These are just like to work out of, okay? If there's answers in them, don't assume they're right, because some people do them wrong. I'd grab one and share it with someone beside you or whatever. You don't all need one. The catch is, page 12 to 14, I want you to cross off all of 4. I don't need you to do it. But the way to find the answers, and if you're like, I don't need the answers, don't go to the answers and copy them. That's a bad idea. But you do the question, then you check the answers, right? That's what you do. In these workbooks, the answers come right after the assignment. They're not in the back. So if this is page 12 to 14, I just flip this assignment until I get to the very back of that assignment, and then there's the answers. The next lesson would have the answers behind it, right? So they're right behind it. So grab a workbook, one of these blue ones, and page 12 to 14.